Chapter 8, Exercise 14. Survey of the mean amount of cents off that coupons give was done by randomly surveying one coupon per page from a coupon section in recent San Jose Mercury News. Following data were collected, so we have a set of data here. Assume the underlying distribution is approximately normal. So they want us to find the mean, standard deviation, and sample size. So what I did was I inputted the data into the calculator, and I had the data in list 1, and I typed it in as decimals. So looking at this as 0.2 of a dollar, which is 20 cents, and 0.75, which is 75 cents, etc. Now I might be interested in changing my units here so that I'm dealing with cents instead of dollars. So what I'm going to do is just do a quick little conversion here. I'm going to put my cursor up to L2. So down here I have L2 without any parentheses. I'm not looking at any particular element. And so I'm going to take L1, and each of these numbers in L1 I'm going to multiply by 100, and that'll convert everything into cents. So 20 cents, 75 cents, and if I scroll down, one of the coupons had $1.50 off, and so we're looking at 150 cents in that case. So they want us to find some basic statistics. Let's go to Stat and Calc. We're going to do a 1var stats, and remember that our information was in L2. So in 1var stats in L2 will give us these statistics. So we'll go with 53.9 cents for your X bar. And remember that the standard deviation is Sx, not sigma x. So we'll go at a 31.6 cents. And our n is 14. N minus 1 is 1 less, that's 13. It's kind of strange to ask for n and n minus 1, but n minus 1 happens to be an important number for certain distributions, like in this case we're actually going to be using a t distribution. Part B, define the random variables x and x bar. So we're looking at amount of cents off that coupons give. So x is going to be amount of cents off that a coupon will give. Whereas the x bar would be the mean amount of cents that in this case there's specifically 14 coupons give. A little awkward in the statement here, but that's how it's kind of brought up, so that's how we'll put it. Part C, which distribution should you use for this problem? We will of course use the x bar since we are looking for the mean. So we're approximating the mean using confidence intervals, so it's just natural to use the mean distribution, the x bar. Okay, part D asks us to construct a 95% confidence interval, sketch a graph, and calculate the error bound. So if we take a look at this setup, we'll go to Stats, Test, and we're going to scroll down and choose between a z interval and a t interval. And here we're going to use the t interval. use the t-interval because sigma is not known. Remember, we only use the z if we know sigma. Otherwise, we will use a t-interval. So we will be using the t-interval. Let's go ahead and select that. Now we have statistics. Actually, the calculator populated our statistics input here from our calculation in one of our stats. But let's say we didn't have that. We just have the original data, and this will give us an opportunity to use this data option. So I'm going to select data. It's blinking over here right now. Stats is selected. Data is blinking. I will press enter to select data. The list that I want to access is L2. The frequency is going to be 1. And my confidence level here in this problem, they want the confidence level to be 95. So I'm going to select a 95 confidence level and calculate. In our calculations, we get a confidence interval between 35.6 to 72.2 cents. So let's call it 35.6, or let's say 35.7. And we're estimating the mean, so we'll use the mu for the population mean that we're estimating, and 72.9 or 19, so 72.2 cents. Sketch the graph. We can just do this curve over here. We got our mean to be 53.9, and we have a shaded region of 95%. That gives us a tail region of 5% on both sides. So half of that is 0.025, half of 5%, 0.025. And then we actually have our confidence interval here, 35.7 and 72.2. So that's our graph. We want to calculate the error bound. So the error bound for the mean is a couple of ways to do this. One is to just take the difference between these two. The other is to take the difference between the endpoints of your interval and then cut it in half. So since we have this already, we'll just go with typing in a 72.2 minus 53.9. And that's 18.3. If many random samples were taken, size 14, what percent of the confidence intervals construction should contain the population mean worth of coupons? So in this particular problem, they're talking about a set of random size of 14. What percent of confidence intervals constructed should contain this population mean of coupons? So imagine that this is the real population mean, and you have confidence intervals here. And so let's see if we can do this. Let's say this particular confidence interval we got to look like this. We select another confidence interval and then another confidence interval, and you can see that most of these confidence intervals will actually capture the mean. And maybe one of them does not, out of a whole bunch. And so this particular question is, out of all these samples of size 14, they're asking us what percent of confidence intervals constructed should contain the actual population mean worth of coupons. So with that, I think we'll go with this idea that that's what that is, the 95% confidence. So 95% of the samples will contain, or should contain, let's use the word that they use, should contain the true population mean. So that's the point of selecting a confidence interval. Okay, I hope that helps.